Thank you. Hello. Thanks for great talks. So I saw the members of the Bytecode Alliance, and I didn't see any blockchain-related company in there. And blockchain is actually a big part of both Rust and WASMer. 40% of sponsorship, as far as I know, comes from blockchain-related companies when it comes to the conferences in Rust. And WASM becomes like a big part of the stuff that people actually use for the second generation of the blockchains. And the requirements that blockchains have towards WASM are very specific in terms of determinism and like all kind of gas injection, etc. What Byte Alliance is doing in that area, and what are the plans? Thank you.
We are already talking to a few blockchain companies. This is just the founding set of members. We are bringing on new members, and I'm absolutely certain we'll be bringing on at least one blockchain company. And we'll likely, if we're bringing on more, have subgroups, or because there are very specific requirements for that use case that we've heard about from blockchain companies already. And so giving them a space to, think about what WASI standard, what they might need from WASI, what they might need from other parts of the system makes sense.
To add to that, we also have two companies that are very active in the blockchain space as active heavy contributors to our projects. Parity have contributed the Lightbeam baseline compiler, which is really state-of-the-art. Baseline is almost not the right word anymore. It's not about going about code generation as fast as possible. It's about doing it in linear time so that you can't be attacked by JIT bombs. And Golem are by far the most prolific external contributor to our WASI implementation, WASI Common. And we have, if you look through Git history, then you see other contributions to our projects from blockchain companies, and those don't happen without a reason. Also, one thing on the non-determinism, Grainlift, our code generator, actually, as does Lightbeam, has a mode that is fully deterministic, because in the WASM spec, the only thing that isn't fully deterministic is NaN handling, and Grainlift can be operated in a mode where it makes that fully deterministic, which obviously is driven by this use case.
And this is also something that sandboxing helps a great deal with, to help you know that something you're running is entirely deterministic. You can know, well, I didn't give it access to randomness, I didn't give it access to the system time, and it's not multi-threaded. So whatever it's doing, it will give the same answer every time.
Thanks for organizing, and really thanks for the great talks. One of the first major use cases outside of the browser is running web workloads, or at least workloads that have access to HTTP. How can one get involved in the proposal, and what's the status of that for WASI?
I guess de facto I'm leading the HTTP proposal because I got stuck with it. I gave a talk a couple months ago that was a straw man of what we might want this to look like, and right now I'm still laying essentially groundwork of getting some of those ideas into WASI about futures and streams. And Fastly is going to be showing people about our not standard yet, but hopefully standards track implementation of that soon, though we don't have a concrete date yet. So please do get in touch with me. I would love to hear about your requirements and your use case. And the other aspect of this is, so for the Fastly environment, we only want to provide access to HTTP. We know in many other environments, access to more general networking is necessary. So there's tons of room to build out things for sockets or for other specific protocols like DNS that you might want access to at a systems interface level. So that's something I think you can come more generally to the WASI group, and I don't know of anybody who's actively working on that, but there might be.
I'm very excited about all of the goals that you've stated. I think it's really cool technology, and I'm looking forward to see where it goes. I'm wondering how you all think about how the mission of the Bytecode Alliance and WASI and the nanoprocesses and the whole ecosystem vision interacts with excuse me, the web, right? The web platform. Obviously, the current security story for the web platform is very different from the security story that you're all trying to fix on non-web platform. The web already has a sandbox. But there are, security issues with transitive dependencies and all this on the web. The web has the advantage of WebAssembly built in. So I think there's a lot of potential to try to make sure that we have compatibility between the ecosystems. So I was wondering what you all thought about that direction.
So I think there are two key answers to that question. One is that we are looking to have compatibility layers and polyfills and similar that allow you to run not just WebAssembly, but portions of WASI that make sense on the web. It is not, despite the name system interface, it's more, these are calls you expect on a system. That doesn't mean it has to be at the low-level operating system rather than the browser, which is an operating system unto itself. So you could have access to file system APIs, and they could give you access to either a sandbox that you can play in, or access to your own web server, or access to a variety of ways of interpreting the concept of file system. And the same goes for many of the other APIs. You might have access to HTTP outgoing connections, but only to your own server, for example, and you wouldn't have raw sockets. So much of the security model and capability model maps very nicely to the web, and it will simply only allow you to run things that use the capabilities the web provides or that we extend the web to provide in the future. The other half is that the shared nothing linking model is very much something that maps naturally to origins in browsers as well, where long-term it would make a lot of sense to be able to say, I want to load this module from this other site, and here's what I know about this module, and here's the permissions I'm willing to give that module. Those permissions are enough to help me, calculate interesting things to render my UI, but not enough to insert script tags or otherwise cause me to run arbitrary code or miners or various exciting things that want to exfiltrate my analytics data or my passwords or any number of other things. So both of those potentially align well with the web. This is not, the Bytecode Alliance is designed around WebAssembly beyond the web. That doesn't mean that it's WebAssembly without the web. And I very much think there is a alignment with the web going forward as well.
Also, another point is the web has a great sandbox for a single origin, but of course XSS attacks are a very real thing. The supply chain attacks Lynn talked about can work just as well when you pull that code into your origin. And so that finer grained isolation within the same origin sandbox is just as valuable. So the thing that Lynn alluded to that we're working on, the linking proposal, this how does a module, when it imports another module, delegate the capabilities so that it can't import them from the global objects, which is the current kind of state of the art with ESM integration. Saying, I want a different way to import a module where I give it the capabilities it had. It doesn't even get to see the global object, the global module map. That will be an improvement even within improvement upon the same origin sandbox.
Does that impact the current ECMAScript module proposal?
I think it's like a V2 to it. It doesn't change. Like everything that's currently written, as far as I know, is great, and we should implement that. And this will be like, oh, and when you use linking, it will have this additional behavior.
Great.
But since no existing code has linking, therefore it's no backwards compatible change or breaking change.
There's one there.
Thank you. Thanks for all the great talks. Just been enthralled. So if I can, I might want to ask a couple questions. But the first is, I think, Pat, you mentioned that in WITX, types are structurally typed, and I'm kind of curious what that actually means. I have a lot of ideas in my head about how I could imagine that.
So in WebAssembly, types are structurally typed. So that was actually one of the differentiating factors between WITX and what interface types will provide. So one of the ideas in interface types is that rather than say the name of a type, you just give the entire definition of that type. And it's because in WITX we want to talk about the names of things in order to generate useful code for like syntax in a programming language versus machine code that implements a specification that we want names around. And so that's why we actually do have that difference of nominal typing in WITX. It does make me a little nervous because having two different kinds of type equality floating around can lead you to think it's going to work out one way and it actually end up another. And I don't feel like 100% confident that we've made exactly the right design choice, but it just seems to be the design choice that makes the most sense for the application we're working on right now. So if I have to go back and end up undoing some of that, then I'll apologize that I was wrong.
Cool. So I definitely misunderstood it, so let me refine my question. So in WebAssembly, if types are structurally typed, what is that structure? Can that structure, I could imagine that structure just being this type is this size of bytes. I could imagine that structure being it's n fields, and each ith field has a certain length. And then I wonder, how do you represent a C union with that? Does that make sense as a question yet?
Yeah, it's a great question. Fortunately, structural and nominal typing is a very context-dependent sort of term. They're not totally clearly defined. So to start with, interface types defines a bunch of values. And the great thing about values is you can copy them. And it's also easy to find coercive subtyping where, you know, if you pass me a record with 3 fields and I want a record with 2 fields, I can ignore the field because I'm making a copy, even if it was a field in the, the beginning, the middle, or the end. That's harder when we're sharing a pointer to the same memory. You need a much stronger definition of subtyping there. So when things are values, we can apply structural subtyping and copy values. When we want to share a reference to the same thing, that's when things get interesting. And what WebAssembly has proposed just in the core standard, even before and independent of interface types, is abstract types in the sense of for all t that are a subtype of X from system F and onward. That's what WebAssembly is going to get. So you can say there's an abstract type and here are the operations on it. And then you can pass around a reference to this abstract type. And then everyone has to agree exactly on that abstract type. And so that's pretty close to nominal typing, but there's not actually a name. So usually people say nominal, there's a name, there's a string. There's no string here. It's I take a for all t and you take a for all t, and if somebody else instantiates both of us and gives us the same t, then we're talking the same type. Otherwise, we're talking different types. So it's a slightly different variation from nominal typing like you see in Java or C++. It's more like you see in the functional languages or old lambda calculi. So there's still more work to do there. In terms of WASI, WASI could say there's an abstract file type, and there's a bunch of operations on that. And is it a nominal type or not is maybe a matter of philosophy, but it's an abstract type.
Cool. And you're referencing essentially the AnyRef, if I get concrete?
AnyRef is a starting point, and then an extension to that is saying there's an abstract type, and I can make a reference to that abstract type, and that's a subtype of AnyRef. And that is a statically typed thing that AnyRef says, I don't really know. A reference to an abstract T says, I know it's a T. I don't know exactly what T is, but I know it's a T. So if you know what a T is and I know what a T is, we can share them back and forth. So it's not giving quite enough information, but it's sort of a tricky topic.
So does that imply that I'm going to be able to eventually import a type from another WASI
Yes.
module?
In fact, I think the proposal is called type imports.
Oh,
because that's
cool.
the whole point.
Okay. Okay, that's starting to link together. I'll go do research on my own. So my second question is around the nanoprocesses. So in my brain, I'm kind of likening them to like ML modules where you can kind of have these like smaller pieces that you can compose. Is that like kind of
Yeah, they're
any inspiration there, or am
Well,
I reading into it?
So we've had a lot of influence from Andreas Rosberg, who is sort of big in the ML module community. They're not exactly ML functors, but they're very much in the spirit of ML functors. So yes, in a sense.
Cool. So that's all. Those are the questions I can remember right now. Thank you so much.
So you probably know about WASMer, and they do things sort of similar to what WASM Time is doing and Bytecode Alliance is doing in general. So what is the relation there in terms of like what are the differences between the projects that WASMer is doing and WASM Time is doing?
Well, one thing is that as they've been bringing WebAssembly outside of the web, they haven't been following some of these security. The nano process concept is one that hasn't been followed in that implementation, and so that is, I think, we want to make sure that we're keeping that security as things move outside of the web. So that's one difference.
The same is true for the package management model. The WebAssembly package manager that they've come up with is very much more, let's build something that kind of works today using analogous tools to other package managers rather than something that helps build the future of package management where you don't necessarily give full trust to every package that you could possibly import, including the 4,000 modules that contain one function potentially.
But also, more generally speaking, they are a competing implementation of a lot of what we are doing in WASM Time, and competition is healthy, and it's excellent that there are multiple implementations.
That's why there's open standards.
Could you expand a bit more on package management and what do you see as the future of distributing WebAssembly modules in a language agnostic way? Essentially, we see a couple of years ago, Docker Hub emerged as the way of distributing container images across different implementations. What's the vision for distributing modules right now? Thanks.
I think one building block is this notion of how does a WASM module link to another and delegate capabilities. Before you have that basic, which is I think going to be working on a core language proposal, it's hard to build up the higher level concepts. So I think that's a prerequisite. And then after that, then it would be really interesting to have that conversation.
Yeah, along the same lines, package management is something where you should have the ability to define what interfaces you are expecting, and then the module provides what interfaces it's providing. And the way that you find out that you pulled in a module that has made a breaking change shouldn't be, well, I sure hope they follow Symver and I get, nice messages that I don't have a compatible version, or, I had a breakage at compile time because the API changed, or a breakage at runtime that I really hope actually visibly shows me that something was broken. Instead, your package management should say, here's what I expect, here's what they provide. If I can translate from one to the other, or if they map one to one, then I know that I'm compatible. And if I declare what I'm compatible with, I also know exactly how old of a version I can still work with and how new of a version I can still work with. Personally, I'm a big fan of declare and check rather than declare something like a version number that you hope is related to the information you actually want, which is, will this work? So that's one, I'm giving that as a micro example of, in general, we want to follow that pattern of, don't just declare the capabilities that you want, declare the capabilities that you need, and those are all we will give you. And then if you run with just those, then you're working correctly. If you expect something else, you simply won't work or build. So much more of a trust and verify ecosystem. Maybe leave the trust part out since we're verifying.
We have a couple more minutes for more questions.
So one potential hole that I can see is that there's still this requirement for transitive trust, right? Now it's not, I need to trust my dependencies to not do anything bad and all their dependencies to not do anything bad because of the sandboxing and the capabilities. But I still need to trust my dependencies, which I need to pass these dependencies some mildly sensitive capabilities. I need to trust that those don't transitively pass those capabilities on to further down modules that maybe I wouldn't have trusted myself, right? And there's kind of like maybe this fall off of trust with depth from the root module. Is there any thought about how to solve that problem?
Hopefully one thing that could help if we have these basis of, look, at least we're attempting to restrict the capabilities and declare them, we could start to think about visualizations of package dependencies and tools that enable developers to look out over a whole tree and have some sort of classification like, is the set of capabilities requested here in like kind of the safe zone or in kind of a you better look zone or a, oh, that's real dangerous zone? That's not yet defined. I think we need the building blocks before we can talk about that, but my hope is once we have those building blocks, we can start to explore interesting tools to help people. Ultimately, auditing is necessary. This doesn't solve the problem. This is more in the defense in depth, principle of least authority category that's in between the current state of the world and like absolutely secure. I don't even have to look, somewhere in the middle, but I think we can improve a lot in that middle.
Related to that, there's a really critical reason why we're building these capabilities and this permission system before we build out, say, a package management ecosystem rather than after, because the infrastructure very much helps determine what kind of community and ecosystem you get around it. So if we have, from day one of our package management solution, we have a capabilities system, we have a nanoprocess isolation system, then we know that we have a world where you don't expect a module for, say, padding strings to ask for capabilities to write to network sockets. But beyond that, the transitive trust problem is at least somewhat mitigated by the idea that if I am pulling in a module that has a particular set of described capabilities, I'm going to raise really interesting questions if that is asking for permissions it shouldn't need. Now, obviously, that is not a complete panacea, because that means, okay, attackers will focus harder on modules that ask for all the capabilities they need. So if what you have is, say, a web rendering framework that needs 27 different capabilities to do its job, then that would be a great target to go look at. But even then, that is an area you can focus on, have all your security researchers look at, and it itself knows to be responsible about, just because I have 27 different capabilities doesn't mean that the module that I call to render fonts needs anything other than, data of a font and output to whatever screen abstraction I have, and it certainly should not have other capabilities. So we, in a way, turn the huge compositionality that you see in other ecosystems that is considered a bug in those ecosystems almost, of like you have 4,000 modules to do something simple, and we actually turn it into a feature where of course you want to decompose it because you want to give less permissions to the parts that need less permissions. So introduce more modules so that you can introduce more module boundaries and minimal permissions.
There's also another part to this. So right now, getting a supply chain attack in a minor version upgrade is way too easy. But there's also another part of this where ensuring that you're not getting a supply chain attack in a minor version update is almost impossible right now. Because have you tried getting from 0.3.1 to 0.3.2 upgrade of some version, getting the diff of those two packages? The amount of hoops you have to jump through to even see what has changed between those different versions, it's ridiculous. So in some ways, there's way more that we need to fix in our supply chains. But getting to the point where you actively have to care because otherwise your build doesn't succeed, that helps a lot, I would say.
Any more questions? This might be the last one. Cool. Oh, maybe? All right, let's do it.
First time I used WASM BindGen, I thought it was the most magical piece of software I've ever used. While the interface types is still in flux, do you see, two parts. What is the state of trying to have a BindGen module for outside of the web, for non-JavaScript languages? And how is that we're going to be impacted before and after the interface type has solidified?
Hey, Alex, get up here and take a mic.
Wait, so the first part of that question was, what do we do about other languages? Yeah. So I know probably one of the biggest ones for compiling to WebAssembly is C and C++ and figuring that out. And I know Dan and Nick here have actually had some other ideas there. It's not going to be easy. It's very difficult in the sense that Rust has a lot of very unique capabilities with procedural macros that make it very easy to do this. But the same ideas are very spirited along those lines. I suspect that WASM BindGen itself is far more powerful than what you need for interface types. It has lots of JavaScript stuff in it. And so if you strip it down to just what interface types is, which is sort of this precise that we want with cross-language ecosystems and things like that, it's not going to be too hard to, I could imagine, to get there. So it's going to be very domain-specific, very language-specific, and there's like some ideas of how we can smuggle information through LLVM all the way back to the other end of the linker and reconstruct it into a WebAssembly interface types module. But it's going to be a little difficult and take some time there. And so we're definitely, those are the two main targets we have in mind right now, Rust and C++, but we're looking for kind of inspiration for other ideas and for other languages. And remind me of your second question.
Just quickly.
Do interface types?
When will WASM BindGen do interface types is right now and also yesterday. So it's had support for some time now. It used to be called WebADL bindings, and it had support for that. And now it's called interface types, and it now has support for that. So currently in Nightly, we haven't actually published a version of this yet, but it's all in the WASM BindGen master branch of you can produce a module with interface types as currently specified. You can also consume a module with interface types and produce a JavaScript polyfill. And so all of that is currently supported. It's naturally incredibly unstable because there's not even a binary format specification, but at least for demo purposes, you can kind of play around with it, look at it, inspect it, see what's going on there.
And there are also some members of the Emscripten team here tonight who are also obviously working on getting interface types support into Emscripten and thus into C, C++, and related toolchains.
And I think it's worth pointing out, this is one case where we're very aware that these technologies have uses beyond, not only beyond the web, but beyond WebAssembly even, because interface types is incredibly important for hooking languages together when they are multiple shared nothing WebAssembly modules. It's also really useful just as an IDL that tells you how to connect two modules together, whether they are mutually distrusting or not. So we see a lot of fun applications for WebAssembly interface types in the future as well.
Cool, I think that's all we have for the panel. So a round of applause for everyone who spoke. Is this on? All right. Thanks, everyone, for coming out tonight. Thanks, everyone, for coming to a year's worth of WebAssembly talks. Yeah, round of applause for all the speakers we've had throughout the year. 2020 will have even more talks. I already have submissions for the beginning of the year. If you want to talk about the things you're working on, your company, or ideas you've been hacking around with, please reach out to me because we're definitely going to be continuing on through 2020 and scheduling those out. For tonight, we have, let's see, until 9 o'clock until we have to get shimmied out with the big hook. We have plenty of drinks left. The pizza's gone, but please finish everything we have so I don't have to carry it home. And yeah, see you all next year. And thanks again to the Bytecode Alliance for hosting tonight.
And John.